A billion-dollar defense system does not always fail because it is weak. Sometimes it fails because it has no time to think. Oh, what happens when Oreshnik enters the sky and Patriot only gets seconds to react? This is not a simple missile duel. This is a countdown. Most people ask the obvious question: can Patriot stop Oreshnik? But that question is too small. The real question is much darker. Can Patriot see it early enough? Can it understand what it is seeing? Can it calculate the path, choose an interceptor, and fire before the window closes? Because Patriot is not just a launcher. It is a layered machine of radar, computers, commands, and interceptors. Every part must work in sequence. One sensor sees, one system calculates, one operator confirms, one interceptor launches. Then everything depends on timing. But Oreshnik represents the opposite idea. It is not trying to give defense time. It is designed to compress the battlefield. Less warning, less certainty, less room for correction, and that is the nightmare. If Patriot sees the threat too late, the chain starts late. The radar track is unclear, the computer waits. If the system hesitates, the interceptor loses distance. And if one link slows down, the whole defense network starts falling behind. That is why this fight is not really about speed alone. It is about decision pressure. Patriot may have advanced sensors, it may have powerful interceptors, it may have a proven layered defense concept, but every layer costs time. And against a fast incoming threat, time becomes the battlefield. So who is under more pressure? The missile racing toward its target, or the defense system forced to make perfect decisions in seconds? And if Patriot can stop one incoming strike, can it keep doing it again and again? To answer that, we have to open the system itself, step by step, sensor by sensor, decision by decision. Because before Patriot can intercept anything, it first has to win the race against the clock. But where does the race actually begin? Not at launch. Not when an interceptor leaves the ground. It begins with detection. Because Patriot cannot stop what it cannot see. Before anything fires, the radar must wake up, must search the sky. It must find a target moving fast. Then it must keep watching long enough. Long enough to build a track. Long enough to measure speed. Long enough to understand direction. And long enough to answer one brutal question. Is this object a real threat? That is step one. The radar is the first eye. It scans, listens, compares, and updates. But here is the problem. Fast target does not wait politely. Every second it moves closer. Every second the geometry changes. If detection happens early, the system gains breathing room. If detection happens late, everything behind it gets crushed. The radar may still see the object, but seeing is not the same as understanding. Well, what happens next? The system must classify the threat. A bright dot on radar is not enough. It could be the real body. It could be a fragment. It could be noise. It could be something moving in a confusing pattern. The defense system cannot just panic and fire. That sounds simple. It is not. If it fires too early, it may waste an interceptor. If it waits too long, the intercept window shrinks. And if it misreads the target, the entire defense chain turns blind. This is the hidden pressure behind modern air defense. The hardest part is not always launching. The hardest part is knowing what deserves a launch. Patriot has sensors and computers for that reason. They sort signals. They compare movement. They build a threat picture. They try to separate danger from clutter. But against a fast incoming object, time becomes a filter. There is less time to clean the data, less time to confirm the picture, less time to ask, are we seeing this correctly? Then comes the next layer. The system must predict the path. This is where the battlefield becomes math. The radar sends information. The computer builds a track. The system estimates where the target is going. Then it calculates where an interceptor could meet it, not where the target is now, where it will be seconds later. That is the nightmare. The interceptor is not chasing a frozen point. It is trying to meet a moving future. And the faster the threat moves, the worse the margin becomes. A tiny error can grow fast. A small delay can become a missed meeting. A slight uncertainty can move the intercept point. So the defense system has to be fast, but it also has to be accurate. Fast without accuracy is just noise. Accurate without speed is too late. Patriot has to be both at once. Now comes the human decision problem. Should the system fire? Should it fire one interceptor? Should it fire more than one? Should it hold fire for another target? This is where defense becomes resource management. Interceptors are not endless. Launchers are not magic boxes. Every shot changes the next decision. Use too few and the threat might leak through. Use too many and the battery drains faster. Hold too long and the chance disappears. That is why this is not just a technology contest. It is a pressure test. A commander is not choosing in a quiet room. The clock is moving, the track is updating, the target is closing, the system is asking for a decision, and every option has a cost. Fire now and spend precious interceptors. Wait longer and maybe gain better data. But waiting also gives Oreshnik what it wants. less space, less time, less forgiveness. Here's where Patriot starts to look different. It is not a single weapon. It is a decision factory. Radar feeds the machine, computers shape the picture, operators watch the threat, launchers prepare the response, interceptors become the final answer. Each step seems logical alone. Together, they form a chain. And chains have a weakness. They only move as fast as their slowest link. Bo, what happens if the decision is made? The interceptor leaves the launcher. Now the race becomes physical. It must accelerate fast. It must receive guidance. It must adjust its course. It must close the distance. And it must do all this while the target keeps moving. This is the final layer. The clean radar screen becomes a violent timing problem. At this point, every earlier decision returns. Was the target classified correctly? Was the track stable enough? Was the launch ordered early enough? Was the intercept point calculated well? If the answer is yes, Patriot has a chance. If one answer is no, the system loses precious seconds. And against this kind of threat, seconds are not small. Seconds are the battlefield. That is the brutal logic of layered defense. Each layer protects the next one, but each layer also consumes time. Detection takes time. Classification takes time. Calculation takes time. Command takes time. Launch takes time. Guidance takes time. And Oreshnik's entire concept pressures that timeline. It does not need every layer to fail. It only needs enough layers to run late. So, before anyone asks if Patriot can stop it, ask this instead. How early does Patriot see it? How clean is the track? How fast can the system decide? How many interceptors can it spend? And how many times can it repeat that process? Because the first battle is not in the sky. It is inside the chain. A chain of sensors, computers, launchers, and decisions. Patriot is advanced. But advanced systems need coordination. Coordination needs time. And time is exactly what Oreshnik tries to take away. First, it does not need to smash through. It only needs to steal seconds from every layer. Then the real question becomes much deeper. Because what if speed is not the real weapon? What if the real weapon is compression? That is the twist. Oreshnik does not just challenge Patriot's interceptor. It challenges Patriot's entire decision chain. Every radar sweep, every calculation, every confirmation, every launch command, every correction in flight. It squeezes all of them into a smaller window. So, if the system is advanced, why is it still vulnerable? The answer is simple, but uncomfortable. Advanced systems need time to be advanced. Radar needs time to build a clean track. Computers need time to compare possible paths. Operators need time to confirm the threat. Launchers need time to respond. Interceptors need space to maneuver. Take away time, and every strength becomes harder to use. This is where the fight changes. Most people imagine a missile trying to overpower defense. But this is not only about raw power. It is about forcing defense to rush the detection, rush the classification, rush the launch decision, rush the intercept geometry. And once a system starts rushing, small errors become dangerous. Think of Patriot like a layered shield. Each layer has a job. One layer sees, one layer sorts, one layer calculates, one layer launches, one layer guides the interceptor. On paper, that sounds strong. But here is the problem. Every layer also consumes time. The more complete the shield becomes, the more coordination it demands. So, can more layers create more pressure? Yes, because every layer needs clean information. If the first layer sends uncertain data, the second layer inherits doubt. If classification takes too long, calculation starts late. If calculation starts late, launch time disappears. If launch time disappears, the interceptor has less room. The system is still smart, but it is being forced to think faster. This does not mean Patriot is weak. That is the wrong lesson. The real lesson is sharper. Modern defense is incredibly complex. It works by building confidence. It wants to know before it fires. It wants to avoid wasting interceptors. It wants to protect the target. It wants to save ammunition for later. But Oreshnik pressures every one of those goals. Now comes the cost problem. If Patriot intercepts one incoming threat, is that victory? At first, yes. The target survives. The defense worked. The system did its job. But in a longer campaign, one intercept is not enough. The real question is much harder. How many interceptors were used? How many remain? How fast can they be replaced? How many crews can sustain that pace? This is called the exchange problem. One side spends to attack. The other side spends to defend. If defense must spend more each time, pressure builds. Even successful defense can become expensive. That is the hidden trap. A shield can win a single moment, but still lose the larger map. Imagine one incoming strike. Patriot fires one interceptor. Maybe it works. Now imagine the system fires two. The odds may improve. But the cost doubles. Now imagine several incoming threats. The battery must choose priorities. Protect this target. Hold fire on that one. Spend now. Save later. Every choice becomes a budget decision. That is why the question changes again. It is not only can Patriot stop Oreshnik, It is, can Patriot keep stopping it? Can it do it repeatedly? Can it do it under pressure? Can it do it without exhausting interceptors? Can it do it while tracking more threats? Can it do it while staying calm? This is the battlefield nobody sees. Not smoke, not fire, not dramatic explosions. It is a silent contest of seconds and resources. The attacker wants to compress time. The defender wants to buy time. The attacker wants doubt. The defender wants certainty. The attacker wants to force spending. The defender wants to spend carefully. Why is this a one-on-one comparison misleading? Because Oreshnik and Patriot are not two boxers. They are two systems with opposite philosophies. Oreshnik represents speed, pressure, and uncertainty. Patriot represents detection, calculation, and layered response. One tries to make the problem smaller in time. The other tries to make the answer bigger in structure. That is why numbers can fool people. Speed matters, accuracy matters, range matters. But systems do not fight as isolated numbers, they fight as chains. A fast weapon can stress a slow decision. A complex defense can protect many targets, but it must keep the chain moving. If the chain slows, the advantage starts shifting. And here is the deeper twist. Defense must often be nearly perfect. It must see correctly, it must classify correctly, it must calculate correctly, it must launch correctly, it must guide correctly. The attacker may only need one mistake, one late detection, one bad track, one wasted interceptor, one overloaded decision window. That is an asymmetric pressure, not because one side is magic, not because the other side is useless, but because their burdens are different. The attacker wants disruption. The defender wants reliability. Disruption can be messy. Reliability must be disciplined, and discipline becomes harder under a shrinking clock. So, who is really under more pressure? The missile racing through the sky, or the defense network making repeated decisions? The missile has one mission, the defense has many. Detect the threat, confirm the threat, choose a response, protect the target, preserve ammunition, prepare for the next wave. This is the part most people miss. The real contest is not metal against metal. It is time against process. It is speed against certainty. It is pressure against discipline. And behind all of that, it is cost against endurance. That is why Oreshnik versus Patriot is not simple. It is not a clean scoreboard. It is not one shot, one answer. If Patriot succeeds once, the story continues. If Oreshnik forces repeated launches, the story changes. The defender may survive the strike, but the attacker may still drain the system. And that leads to the final question. One side only needs to steal seconds. The other spends millions buying them back. So what is the real weapon? The missile, the interceptor, the radar, or the clock itself? And that is where the answer becomes uncomfortable. The real fight is not one intercept, it is repetition. Can Patriot see the threat early enough? Can the computer understand the track fast enough? Can the system choose the right interceptor? Can it launch at the perfect moment? And can it afford to keep doing that? That is the hidden cost of defense. Every second bought has a price. Every launch consumes a resource. Every decision spends part of the battery's future. So the question is not only can Patriot stop Oreshnik, the better question is how long can it sustain the chase? Because the attacker wants compression, less warning, less certainty, less room to correct. The defender wants the opposite, more time, cleaner data, better classification, more confidence before launch. These two ideas collide in the sky. If Patriot succeeds, the target may survive, but the story is not over. The system must reload. The crew must reset. The radar must keep watching. The computers must keep sorting. The interceptors must still be available. And the next decision may arrive even faster. That is why this battle cannot be reduced to headlines. It is not just speed versus defense. It is time versus process. It is pressure versus discipline. It is one incoming threat against an entire decision chain. So what matters more, Oreshnik's speed, Patriot's precision, or the cost of every shot fired? That is the question behind the weapon matchup. And it is the reason this contest is so difficult. Oreshnik versus Patriot is not simply missile against missile. It is not a clean answer. It is not a scoreboard. It is a battle between two philosophies. One side tries to steal seconds. The other side spends millions buying them back.